Hello everybody, we're going to talk today about unit rates and proportions and using proportions to solve some word problems. When we talk about unit rates, we're talking about a cost per one. Unit means one, and we want to know if we have a bunch of things, how much would it cost to buy one of them, or to drive 1 mile, or to do one thing. Here's 3 different kinds of soup. So we have super soup, we have chunky chowder, and we have brothy bisque. And these 3 different soups have different prices. I can buy super soup, 3 cans for $5. Chunky chowder costs 4 cans for $6, and brothy bisque costs $7 for 2 cans. So the question is, which of these is the better buy? So I can tell that by comparing their unit rates. Unit rates means their cost per one. And this is really just a division problem. This would be $5 divided by 3 cans. This would be $6 divided by 4 cans. And for our brothy bisque, we're paying $7 for 2 cans. And I divide those out. I take my calculator, I'm reaching over to get my calculator, and I divide those out. So super soup costs $1.67, if I round, $1.67 per 1 can, which makes sense. If I'm only buying one of them, I would only have to pay $1.67. If I divide out my chunky chowder, 6 divided by 4 would be $1.50 per 1 can. And if I buy this brothy bisque, 7 divided by 2 would cost, that's a little more expensive, $3.50 per can. So that unit, when we talk about a unit rate, we're talking about per one, the cost per one. And it's just a division problem. We divide it down to figure out kind of how much that cost is spread out over those 3 cans. How much would it cost per one? And all unit rates, all done the same way. You just divide. We're going to talk about proportions. Proportions are 2 equivalent ratios. Here's a ratio. It costs 3. We could get 3 cans for $5. We could make an equivalent ratio like 6 cans of that same soup for, well, that would be $10. There's infinitely many equivalent ratios. We could say 24 cans. I can buy 24 cans of soup. Let's see, if I multiply by 8 would cost me $40. Usually when we're talking proportions and ratios, we don't have these units in here. It's just a comparison of numbers, but it's all right to have them there. So we talk about these proportions. Here's a proportion with a missing component. We're missing this value. And we need to know how to figure out how to solve these proportions. So this is kind of our takeaway from the lesson today, one of the takeaways. When we solve these, we talk about cross products or cross multiplying. So I don't like you to use the word cross multiply until this point in the year. Usually when I hear kids coming out of junior high saying cross multiply, they mean multiply across, as in we're solving an equation, we're multiplying fractions. When we talk about cross multiplying, we're talking about a proportion, 2 equivalent ratios compared in that way. They are equal to each other. And what we do is we multiply across the diagonal. We do 9 times 30 equals, and then we multiply these two, 15 times x. Don't forget the multiplication symbol, the equal sign in there. 9 times 30 equals 15 times x. That equal sign is the important part, because now we know how to solve this. 9 times 30 is 270 equals 15x. And then to solve, I would divide by 15. And if I do 270 divided by 15, I get 18. So that x equals 18. Now, in this original proportion, you may have seen that it was going to be 18 anyway. We go from the left to the right by multiplying by 2. From 15 to 30 by multiplying by 2. So 9 times 2 should give us that value. So if you can see the answer to a proportion right away, go ahead and solve it. No big deal. Sometimes, though, those multiplications aren't that easy. For example, here, 5 times what gives me 4? I don't know. So let me use that cross multiplication idea. I'm going to multiply 9 times 4, 9 times 4, and that's equal to 5 times x So 36 equals 5x, and then I'm just going to divide by 5, and x would equal whatever 36 divided by 5 is. X would equal 7.2. Okay, so it's a nice, easy way to solve a proportion, and these proportions come up all the time. They're really, really useful in the actual real world. Here's 4 quick ones. Again, cross multiplying. It doesn't matter where the x is, the idea is the same. That's going to be 7 times 12 equals 42 times x. 7 times 12 is 84 equals 42x. Divide by 42, and x will equal, I think x equals 2. I made that problem up. That worked out pretty nicely. Wow. Same idea in the next one. Now the x is in the denominator of the second fraction, but same idea. 3 times x equals 19 times 5, which is 95. Divide by 3, and x equals 31.6 repeating. Okay, so it's cross multiply. These last two, same idea, except watch what's going to happen now. 7 times x is 7x. Now when I go to multiply here, I run into a little wrinkle. That numerator that's called a binomial, there's 2 terms there. But I treat this like I would any other multiplication problem. That's 3, not just 3 times x, 3 times the quantity x plus 4. 7x equals 3x plus 12 if I distribute. And then I can subtract that 3x. 4x equals 12, and divide by 4, and x will equal 3. So the idea with these problems is we want to make sure we are distributing. Same thing here, that would be 5 times the quantity x plus 4 equals 7 times that whole denominator, x plus 2. And we can solve from there. 5x plus 20 equals 7x plus 14. Remember, in these problems, I'm going to decide what I'm going to do next. And I think for our purposes here, I'm going to subtract 5x from both sides. So 20 equals 2x plus 14. And continue from there, subtracting the 14. Gives me 6 equals 2x. Divide by that 2, and x equals 3. Okay, so these are quick, easy problems to solve. But they do come up with the equation, so they're good to go over. I want to look at 3 little word problems, and then you're going to jump over to Delta Math. These came directly from Delta Math. I want to show you how to set these up. This says, a grocery store sells a bag of 8 oranges for $4.32. If Colton spent $5.40 on oranges, how many did he buy? So the idea here is these are 2 equivalent ratios. 8 oranges cost $4.32. How many oranges can I get for $5.40? Now make sure, the only trick here is make sure you put the right piece with the right piece. I chose to put oranges on top and money on the bottom. So in the other ratio, I need to do the same thing. Oranges, that's my unknown, that's where my x will go. And then the ratio down below would be in dollars. And now I cross multiply. 8 times 540 equals 432 times x. 8 times 540 is 43.2 equals 4.32x, and I divide by that 4.32 and I get x equals 10. So Colton bought 10 oranges. Okay, so put the right piece with the right piece, and then these are pretty simple. Let's do 2 more. Madeline's car used 15 gallons to travel 390 miles. 390 miles in 15 gallons. How many gallons of gas would she need to travel 156 miles? So if I put the miles up here and the gallons down here, I'm looking for gallons, so that'll be my x. And she traveled 156. Cross multiply, 15 times 156. 15 times 156 gives me 2,340 equals 390x, and I'll divide by that 390, and I get x equals 6. So she would need 6 gallons of gas to travel 156 miles. I could have rearranged those numbers differently. It doesn't really matter as long as the right piece goes with the right piece. And we'll do one more. Last 1 week, Abigail earned $396.80 at a job where she worked 16 hours. If she's paid the same hourly wage, how many hours would she have to work to earn $148.80? We're looking for her hours, so that's our x that goes on the bottom. As we solve these, we want to just make sure that our answer makes sense. She should be working fewer hours to earn less money. 16 times 148.80 gives me 2380.8 equals 396.8x. And I'll divide by 396.8 and I get 6. X equals 6. So she would have to work 6 hours and I would type 6 there. Okay, I want you to jump over to Delta Math. There's 5 questions on unit rate and 5 questions on trying to solve these proportions. Okay, and do your best, and we'll see you in Zoom tomorrow. Bye-bye.